All right, here we go. We're live in second hour today, and these guys are just jacked up about being on the video. And they're also trying to get me to say swear words so I get fired. So that's I appreciate that. Thanks, Riley. All right, so same topic as yesterday, except for a little bit different. So we're going to build on this sequences concept. So today we're going to jump around in the sequence a little bit. First question. I like this one. During a thunderstorm, do you ever do this? You can count the seconds after the lightning strikes, and then you hear the thunder. And so what I always thought was that it was like, well, let's just take a survey. What do you think? How far do you think it is away? Like if you count 3 seconds, how far away was the lightning? Yeah, that's the misconception. I don't even know if that's the right word, but it's not a mile per second actually. Does anyone know how many miles it is per second?
50.
No. I heard from Paul Douglas on KARE 11 that it is 7 seconds is a mile. So if you can count 7 seconds, that's what I heard. You can fact check it. I don't even know. Somebody can look it up. But so if you count 7 seconds and then you hear the thunder, then it is 1 mile away. So yeah. Anyway, pretty neat. Anywho, so that's what this scenario is talking about, and the thing from this little slide that we want you to understand is that they are going to have a constant difference in your sequence. So if you have an arithmetic sequence and you count, like let's jump over to the next page here, and you count, so like let's say you recorded some data or something, and you're like, oh, 1 second and it was 0.2 miles away, and 2 seconds it was 0.4 miles away, and if it's going to be like an actual sequence, what we're working with, like an arithmetic sequence, then you're going to be adding some constant number to each term as you go up in a constant manner. So that's what this is talking about, is like, and this one I think is indicating that every 5 seconds would be a mile. So there is some controversy here as far as what I've heard and what the math book is saying, but it's probably somewhere in between there. So let's just call it 6. Anywho, so the new term on this slide that you want to be familiar with is this constant or common difference or constant difference term. And that right there is talking about what it's going up or down by each time. So if it's arithmetic, it's like plus 0.2 each time, plus 0.2, plus 0.2, plus 0.2. Okay? Any questions on that? If it's not going up by a constant difference, then it's not an arithmetic sequence. Know what I'm talking about? Okay. All right, plugging right along here. If you had to determine whether a sequence was arithmetic or not, you would look at their constant differences. So if we take a look at this problem, and how does this show up on your notes? You probably see the whole thing, right? Yeah. So you can see the whole deal. But if I pull down this, this is suspenseful, I know, but if I pull down this shade, whoa, wait a minute. Whoa, lo and behold, the constant difference is 6. So the difference between each term is 6, and so therefore we can proclaim that this is an arithmetic sequence, and a common difference is 6. And the next term is 20, because you'd have to add 6 to the next one, you know. You know how that works. So we'd ask you, hey, determine if it's an arithmetic sequence. You would find all the differences between each term. You'd say, oh, look, they're all constant. We're adding 6 each time. So to get to the next one, I'd add 6 more. I'd get 20. Okay, follow that? Again, the math behind it's not super difficult. It's just understanding what the terms are and what the symbols mean and all that stuff. Okay, let's go ahead and try one on our own here. So let's see. If we want to know whether this is arithmetic, we got to find all the differences between each term. So what's the difference between -2 and -5? Good, -3 there. What about -5 to -11?
6.
-6. Do I have to keep going?
No.
Nope. I can stop right here. Okay. Stop! Stop! And you can, wait a minute, is it 2 A's or 2 B's? It's 2 B's?
Yeah. No, there's 2 A's up there.
It's 2 A's and a B? Yeah, that looks, stab! Anyway, so this is not arithmetic. You want to know a little fact about Staub? He has me sign all the names on his all conference certificates because his handwriting is not good enough to do it himself. Yeah, which is tricky, you know, because if you do it by hand and your hand goes like this, and it screws up one little bit, you screwed up that all conference certificate for that person. It's pressure. It's a lot of pressure I'm put under. What about the next one? Yay or nay? Minus 0.7, right? Minus 0.7. Minus 0.7. Minus 0.7. I think it is. So, yes. Common difference of what? Negative 0.7. And the next term would be whatever negative 0.9 minus 0.7 would be. What'd you guys think of that CCR yesterday? I was inspired. I'm going to go find my passion. I mean, teaching is a passion of mine, but I'm going to go find my passion as a fishing guide maybe or something. Bowler, yeah, that's right. I think I could be a professional bowler. Don't you think?
I think so. You should do it.
I'm going to go practice today. I've never had my own ball. General rule for arithmetic sequences. So this is basically the same thing as we did yesterday, but now it's a new rule that incorporates the constant difference. So if you know the common difference, then we can create a new formula to find any term you want in the sequence. If you think about it, if the sequence is arithmetic and you're just adding the same number each time, then what this formula is saying is, okay, here's my starting point. The first term is a sub 1. And if I want to know any term in the sequence, I just need to basically add the constant difference however many times down the road or down the sequence I'm at, right? So that's why they take n minus 1 constant differences away from your starting point. So it's just another formula. This is like the general formula. So there's the explicit formula yesterday that we had, which the explicit formula was a sub n is equal to, what did we have for that one? Anyone remember? I don't think we had a, I guess it depends on the, whatever the sequence is, right? Okay, but we had an a sub n where we had something like, if I just give the one we just did was, or I'll just make one up, we'd have like 3n minus 1 or something, right? That would have been something like yesterday. So the difference between what we're doing today, this is what we did yesterday, right? The difference now with today is now we have this d common difference value, okay? So we're essentially doing the same thing, but it's a little bit different. All right, find the 12th term of this arithmetic sequence. Well, if we want to know the 12th term, we need to know what the constant or common difference is. And so the common difference here would be likely -6. And I'm assuming it is an arithmetic sequence because they tell us it is, so I'm not going to go and check every term, right? So the common difference is -6. So your D is equal to -6, and then this is a problem where we have the big ta-da. And so, if you were going to read the book and look at an example, this is what it might look like. There's the sequence. Step 1, find the common difference, and then you can evaluate by using the formula that you would generate. So 12, where does the 12 come from? Because you wanted the 12th term, right? So n is 12, that's the 12th term. Okay, let's do one ourselves here. I'm going to pause it. I'll give you a chance to do it. I'll give you a head start, and then we'll see if you get it right. Okay, so you had a chance to have a little head start. The common difference, did you find to be -2? Okay, so then you take that -2 and you have to write a little formula. Here's our formula down here. So I'm going to take that -2 or -2, -2 actually, and I'm going to put it down there in for D. And then it says find the 11th term. So you want the 11th term, so that means n is going to be 11. So I replace all n's with 11. And then a sub 1 is the first term in the sequence. That's a sub 1. So then that has to be right here as a -3. So if I evaluate that formula with those values substituted in, I would have -3 plus 11 minus 1 constant differences, which is -2's. So I start at -3 and I add 10 -2's, which is how much? -20, right? So I don't know, hopefully the formula makes sense to you. It's like you're going to go down by 2 every time. So then we already started at a sub 1 right here, right, is -3. And so if I want the 11th one, I'm going to go 10 common differences away. Okay? So you go 10 common differences down the road and you get to your 11th element because it's -2, -2, -2, -2, -2. Well, you can -2 10 times, or you can do multiplication. Isn't that why we invented multiplication? It's repeated addition. It's like a shortcut for adding all the time. So instead of adding -2 10 times, I'm going to take 10 times -2 and add it to -3. So did you get -23? All right. Why don't you give yourself a little round of applause for that? Good job. You just wanted to get on the video there. Riley wanted to get on the video. This video is brought to you by Mountain Frost that can be picked up at your local, where do they sell it again? Aldi's. Went to Aldi the first time. Here's a tip for any of you who've never been to Aldi. Bring a quarter so you can use the shopping cart because you have to put a deposit in. We'll watch the Shoop video or whatever it is later. Let's jump into finding missing terms in sequence here. So we're given a first term and a fifth term, right? So you might be given now terms that are like just jump in kind of anywhere in the sequence. So if I'm given a sub 1 and I'm giving a sub 5 and I know that it is an arithmetic sequence, I should be able to solve for the constant difference because I can substitute values in and have one unknown. So that's what's happening here is we're putting a sub 1 in here. There's your 17. I know that my n is 5 because this is the fifth, the fifth term. They give me the fifth term is -7. This then is a sub 5 here, right? So a sub 5 is -7. A sub 1 is 17. I know that n is 5, so I can solve for my one missing value there, which is the constant difference d. So if I do that and I solve that algebraically, I can solve and find that the common difference is -6. Okay. And then you want to find the missing terms, and you just have to, well, you can do that just by subtracting 6 from each term. So if the common difference is -6, then 6 subtracted from 17 is going to be 11, and 6 subtracted from 11 is going to be 5, and 6 subtracted from 5 is going to be -1. And you could have kind of reasoned your way through that as well, and maybe did the, not made it such a structured substitute in a formula, do the solving algebraically. I understand that maybe some of you can have looked at that and go and kind of guessed and checked maybe a little bit, but if the answers aren't so, the values aren't so nice and neat and happy, then you would want to set up like an equation and have it more structured. Okay. We have an intruder in the room, Mrs. Groutman. So if security could get on that. No one's willing to be security. All right, let's try one here. So by the way, this is 0.0. This is a live stream. I'm live streaming. We should do that. We should see if a class wants to join up with us like across the world and do a live stream joint class. Maybe in Finland. You got any connections? They can listen to an English lesson in English. Yeah? I don't want to make money, man. I'm not selling out for money. By the way, speaking of money, Aaron Rodgers makes $34 million a year, okay? And I think I just guessed, I don't know exactly what I make, but I make like 62,000 maybe. So that means Aaron Rodgers makes 548 times more than I do. Isn't that crazy? No doubt, for being a baby and running around and throwing passes to all those baby little Packer receivers. Anyway, hopefully Aaron's not going to listen to this. This is the fifth term, isn't it? A sub 5 is 0. A sub 1 is 2. And I don't know the common difference, but I know everything else, so I can just plug this all in. I say, all right, well, when is 0 going to equal A sub 1 is 2 plus the n is 5, so 5 minus 1 times d. So you just make those substitutions. You have one unknown, and this is saying 2 plus, wait, it's 2 plus 4 times what number? Equals 0. So then the number, I think, has to be -1/2. The 5 is because it gave us the fifth one, A sub 5. So the given information was the fifth element and the first element. So they could have given us like the 10th element. And then this would have been a 10 in for n instead of a 5. Yeah, you can jump. What do you mean? Yeah. Yep, I think that's the next question, actually. So when you solve this, you get -1/2 for common difference. Okay, and so -1/2 means it goes down by 1/2, so this is 1.5, this is 1, that's 0.5. And the next one would be 0. Gala drank all the water this morning. He's got a sore throat. This cough was soothed by mountain frost. Can be picked up at your local Aldi. Bring a quarter if you want to use the cart. All right, here's the last one, I think. What if they give you, it doesn't have to be the first one they give you. You just have to have two values in the sequence, and you can determine the common difference. So in this case, they give us a sub 8 and a sub 14. All right, if we want to find the common difference there, we have to plug in what we know. And so what we know is that a sub 14 is going to be equal to a sub 8 plus, now it's not just 14 common differences, it's 14 minus 8 common differences, because we didn't start at, it didn't give us the first one, it gave us the 8th one. So the difference in here is that instead of just plugging a 1 in there, they didn't give us a sub 1, they gave us a sub 8. So we have to do 14 minus 8 common differences. Right, so there, if you do that and you calculate that, you end up with a common difference of 12. Okay, and then if you want to evaluate whatever it is you want to evaluate, you just use the formula again, and you know your common difference now, so you should be able to evaluate to find a sub 5. Well, this actually, we don't know a sub 1, so we know a sub, let's see here. What's that? They go on the next page. Here, we'll do one from scratch, and does this ask us to find a sub 1 too? No, it doesn't. All right, well, this says find the 6th term. So the other one said find the first term. Okay, we'll finish this and then I'll go back. So in this one, they give us the 9th, they give us the 9th term and the 12th term, right? So start with the bigger one. Say we have, I'm going to write this out. A sub 12 is equal to a sub 9 plus, now how many differences from 12 to 9? Well, take 12 instead of minus 1, minus 9 times d. So, but instead of a sub 12, we know a sub 12 is 88. So this is 88. And this one, a sub 9, is 64. So really the only missing value that we need to solve for in the equation here is the difference, the d. So when does 88 equal 64 plus, what's 12 minus 9? 3 constant differences away. So that's going to be what? We need 24, so 8. Do you ever look at that and think about 64 plus what number is 88? 24, so then this stuff right here needs to equal 24. So 3 times what number is 24? So constant difference is 8. So now if the constant difference is 8, now I can take that and I can put that right into the equation here, and I can determine whatever term I need. So, but I need to know a sub 1.
Well, on ours it has 3 steps, and it says find D, then find a sub 1, and then a sub 1.
Yeah, so that's weird. So now we need to find a sub 1 to use the formula, right? So how can we find a sub 1 given that we know the common difference, and we have 2 choices to pick. We could use a sub 9 or a sub 12. Which one do you want to use? Probably the smaller one. Okay, so let's say we know a sub 9 and we don't know a sub 1. So now we're going to do the same thing. So like a 2-part equation. So we know a sub 9 is equal to, we don't know a sub 1 yet, plus 9 minus 1 eighths away. Right? So, but we know a sub 9 was 64. Right? So put that in. So 64 is equal to a sub 1 plus 8 times 8. So what is a sub 1? In this case, it looks like it's going to be 0, doesn't it? So my starting point was 0. So now I have everything to use the formula as is here. All right, have fun with that. Happy hump day. Stop at your local Aldi on the way home today and pick up maybe some candy for a good deal. Did you want to say anything?